problems one by one, because even though we can feel that there is a uh, questions having very large shape, but the content or the answer of content is a smaller one. So when you know the theoretical uh, theoretical property behind each problem, uh, it is easy can solve the each one problem. Okay, first problem. Question one: an analog signal x of t is equal to 3 cos 50 pi t plus 10 sine 300 pi t minus cos 100 pi t. Calculate the Nyquist rate for the signal. So when you go for the signal, even though signal is a combination of sinusoidal and cosine functions, and what is the sampling rate or Nyquist rate of this signal? Okay, so first will be right. What are the, so there is three signal is adding together, the combination of three signal. Each signal has, we have to write the frequencies. First signal, uh, actually it is 3 cos 2 pi t formula. If it is in the that form, 2 pi t. So pi t is there. So 2 into some 50. 2 into something is the 50. So that is why f1 is 25. So f1 25 into 2, that is 50 pi t. Okay. So the sine 2 pi t, so that the coefficient should be will be half of this frequency, half. So that is the frequency. F2 is 150. 150 means we have to take this 300 to 300 pi t, which is equal to 300 pi t, which is equal to 2 pi t, 2 pi t f. So we can replace pi as f is equal to half of this one. Thumb rule is half of this one, and f3 is half of this, that is it is equal to 50. So we have three frequency, the signal having 25, 150 and 50 hertz, three signal frequency. What may be the Nyquist rate of this signal if it is going for the sampling? So we say that the highest frequency, we have to say that highest frequency, find the highest frequency. So the highest frequency is, so 150. So sampling frequency should be twice the fs, should be equal to twice the f maximum. F maxima is the Nyquist rate say frequency. So that means 2 into 150 is equal to 300. So even though the signal is some a complicated one, sampling frequency we are taking is the highest frequency. So sampling frequency which is equal to twice the highest frequency. Okay. So next problem. Next problem is find the Nyquist rate and Nyquist intervals of a signal. Find the Nyquist rate and Nyquist interval of the signal. X of t, which is equal to cos 4000 pi and cos 1000 pi. Okay. So this is a product of cosine function. So product of cosine function, you can split cos A into cos B. You can say that this cos A plus B plus cos A minus B by T. Okay. So this is equal to cos 5000 plus cos 3000 minus of this one, pi divided by half. So that first frequency. So now it is a summation of two signal. So first f1 frequency it is equal to the 2 pi of 2 pi of t 2 pi ft, where f is equal to f1 is equal to 2,500. Second is also 2 pi ft. So f2 is equal to half of this one, that is 1,500. So our maximum frequency is 2,500, and Nyquist rate frequency is fs is equal to 2 times of f1, is equal to 5,000 hertz. And Nyquist interval means that is the sampling interval. Sampling interval means 1 by 5,000. Sampling interval means 1 by fs is equal to 1 by 1,000, 5,000 equal to zero point 0.2 milliseconds. So this is a problem can expect regarding the Nyquist rate and Nyquist intervals. Can we move next slide? Next slide. Okay. So next problem. Question: an analog signal x of t is 8 cos 200 pi t. Determine, first one, determine the minimum sampling rate in Nyquist frequency. That is minimum sampling frequency. Minimum sampling rate or Nyquist frequency. If fs is 400 hertz, what is the discrete time signal? And if fs is 150 hertz, what is the discrete signals? This is known as x and t after sampling. X and t is the discrete signals. What is the frequency of the sinusoid that yield samples identical to those obtained from fs is equal to 150 hertz? What is the frequency of sinusoid that yields sample identical to fs equal to 150? So first problem, what is the Nyquist rate? Nyquist rate is, first we have to take the signal. So this is 2 pi ft, 2 pi ft. So the first frequency of this signal has only 100 hertz. First one, frequency of signal is only 100 hertz. So 2 pi ft, so that so 100 into 2, 200 pi t. And Nyquist rate is, Nyquist frequency is fs is equal to 2 into maximum frequency. 2 into f is equal to 200 hertz. Okay, so first problem is okay. What is the Nyquist rate or minimum sampling rate of this one? So normally we say that sampling frequency should be greater than that of Nyquist frequency. So at least if it is a proper reconstruction, uh, it's at least equal to fs should be equal to 2f, or preferably the frequency, sampling frequency should be greater than Nyquist, but it is not too much greater than that of Nyquist rate, or that means there's a condition called oversampling. So next from B. B is, if fs is 400 hertz, what happened? So fs is equal to 400 hertz, that is, it is above the Nyquist frequency. Fs is equal to, so what will be the XNS? Our XN is, so that means the signal we can replace as 2 pi ft. We can replace as, if it is in the x of n, it, after sampling, 2 pi by 2 pi into f by fs. 2 pi by f by fs t, that is the signal will be 200 pi t, pi nt Pi nt means pi n capital T is this signal is after sampling, so that xt should be equal to xn, and replace the signal in nts, it is equal to f by fs n. So that is can be equal to divided by f by fs by fs by fs into n. F is equal to 100 and fs is equal to 400. So 1 by 100 by 400. 100 by 400 is 1 by 4. I will just cancel by these 2, so that 8 goes pi into pi by 2n. Pi by 2n. This is the discrete time. So they are asking is what is the discrete time signal xn t after sampling. So xn is equal to 8 into cos pi by 2 into n. And similarly, what happened to the if it is an undersampling? Fs is less than 150 hertz. So similar one, 8 goes to pi f by fs n, which is equal to what is f is 100 by fs is 150. So 2 pi into f 100 by 150 into n. Okay, so that is equal to 8 cos 4 pi by 3n. And this is a signal which can be replaced if it is a cos 2 pi minus angle, which is the cos theta itself. So this is written as 2 into cos 2 pi minus what may be the signal here. So we can take as 2 pi by 3, so that by combining these two one, this is 6 pi minus 2 pi, that is 6 minus 2 is 4 pi by 3. So this can be written in terms of the 2 pi minus some frequency. So that 2 pi minus some frequency is same as the 2 pi minus theta. Cos 2 pi minus theta is same as the cos theta. So that we can equal to cos of 8 cos of 2 pi by 3 into n. So what is the xn when it's sampling in the frequency of 150? Next, last one, B. B is what is the frequency of the sinusoid that yields sample identically. So 2 pi f by fs, which is equal to 2 pi by 3, where f by fs is a fraction of 100 by 150. So the maximum frequency that can possible is equal to up to 150. Okay. So today we take as undersampling and oversampling, and what is the happening of a maxima if the FSC is equal to 150. Okay, next problem. So this is an we discussed earlier. This is a waveform which is happening in the undersampling condition. If we are taking the undersampling, that is f omega s is less than that of 2 into omega m, where omega m is the highest value, then the spectrum is final spectrum is overlap each other. So overlap each other means the resultant will be a spectrum like this, the other shape of the original spectrum. Because normally, if it is a if this fs is greater than that of 2fm, this is will be a replica of the original signal. Now it is overlap, so that it will be alert. Then for next problem. Next problem. The problem: a signal goes a signal cos 5 pi t plus cos 10 pi t. This sample Find the maximum allowable values of TS. To reconcile the signal, XPT is passing through a low-pass filter. Find the minimum bandwidth required to reconstruct the signal without distortion. So B is first is a simple one. We have to find the sampling or Nyquist period. Second is to reconstruct the signal XPT pass through a low pass filter. What is the minimum bandwidth required to reconstruct the signal without distortion? Okay. So first one, we can from this equation, this is a combination of two cosine waveform. So that 2 pi ft form is this is in the 2 pi ft form. So that f can be obtained by substituting 2 pi ft is equal to 5 pi at. So that it will be f1 is equal to 2.5 hertz, which is half of this one. And f2 is also 10 pi t. So that f2 is 5 hertz. And what is the Nyquist rate means? From these two signal, one is 2.5 and another is 5. From this 2.5, highest value is 5 hertz. So Nyquist rate is twice equal to the highest frequency. So Nyquist frequency Fs should be twice into F. That is equal to 100 hertz. So twice of this 5 hertz, which is equal to 10 hertz. And what is the interval? Interval means we have to take 1 by Fs is the interval. 1 by Fs is equal to 1 by 100, which is equal to 0.1 s. So this is a Nyquist interval of this signal. So what is the minimum sampling of sampling required? Sampling frequency is required to having without any overlap. So next is what is the minimum bandwidth requirement to reconstruct the signal without distortion. So even though our sampling frequency is Fs is equal to 100 hertz. So 100 hertz means this is the bandwidth is 100 hertz. So in a filter, we can see that uh, filter having lower part and upper part. So total bandwidth is 100 hertz. So that in F side, F1 is 5 hertz and F2 is minus 5 hertz. So that overall, or the bandwidth of this one is 5 minus of minus 5 hertz. That is equal to 100 hertz or 10 hertz. So this is the minimum bandwidth requirement. F1 is 5 hertz and F2 is minus. So that overall Nyquist rate should be equal to 10 hertz. Okay. Switch next problem. The next one, a signal MT equal to cos 200 pi t plus 2 cos 320 pi t. So which is sample f at a Fs is equal to 500 hertz. Draw the spectrum. Draw the spectrum of XF of MT. Second, draw the spectrum of XPF. X is actually this is XF means actually it's the frequency domain. So conveniently you can write as capital X into J omega. Here also capital XP into J omega. So what may be the frequency spectrum of this signal XP. Actually, this notation is never used in any of the textbook. You can use either xj omega. Okay. So from this two signal, we can first calculate what is the combination of two one or addition of two signal. So for what is the f1 value? F1 is half of this one because it is this value is into 2 pi ft. So f can be obtained by 100 divided 200 divided by this 2, which is equal to 100 hertz, and second will be uh, f2 is equal to 160, so 160. And what is the maximum frequency? Maximum frequency is 150 hertz. So draw a spectrum of x j omega. So we can draw a spectrum. We know that there are two samples, two frequency samples are here. So that we can write first sample is frequency is in 100 and second is 160. And similarly in the negative frequency also, so same frequency um, is shown the this side minus 100 and minus 160. So this is a spectrum of a that particular signal because it consists of two frequency also having a positive frequency component and negative frequency component. So next you draw, you can draw the spectrum of xp j omega. Xp j omega is when we multiply this signal with a impulse train so that we get a xp which is a replica nature. So the spectrum is repeating this one. So that actually, if you know well, you can repeatingly shown this one. So XP j omega we can written as 1 by T of sum of XF minus KFS like that. K into sorry K into Fs, and what is the frequency of Ft? We can know the what it is magnitude of this one when it is will be shifted to maximum 500 place, which is equal to 500 into first place. Suppose this is a 500 frequency, 500 uh, adding of 160, that is 500 plus 160, 660. Here it is 500 plus 100, it is 600. And the lower side, it will 400, 340, etc. Like that. So actually, this is a replica of this one. So you can adding or subtracting this combining this signal so that xp j omega will be a replica of the spectrum of this one. So we finish. So we finish portions.